Today I'll do the assignment number 6. I'll first demonstrate my code, and for the code that I've already demonstrated in the assignment number 3, I will not be really focusing on it. I'll just focus on the new things that we've done from the assignment number 3 to assignment number 6. And also I'll upload a version of this code with all the comments on it with the video. So let's start out. I'll be starting with demonstrating the car control.cs code. So let's first start with demonstrating some of the variables. We have here something like the audio source for instance. Like this one is just for attaching the engine sound, and we have something like the Boolean ground here. This is for just it's a Boolean variable for just checking whether our player's car on the ground or not. And here we have the transform ground breakpoint, and this is for to access the new empty game. This is for just accessing the new game object ground checkpoint used for detecting the ground, and the transform is just for moving objects in the Unity. And we have the layer mask, what is ground, and this is a variable for storing the current ground. And in our case, the ground is grounded, is our layer ground, which is we have added one here, which is this one. We can add a new one from here. Also, if you want to add one, yeah, it's in the inspector. So I'll just move the inspector right here to see everything well. Yeah, it works well. Well, I'll also add a scene here for a tab for our scene. Yeah, we'll just add the game here also. Yeah, everything is good now. Well, our position is not shown here, so I'll just make it. Yeah, we'll add our position. So I'll just make the position fixed here. We will go to the position label and position indicator, and we'll fix the position right bottom. So now it's fixed. Now if we went to any aspect, it will be fixed right here. So now it's good, and our goal also, I want to fix it in the middle because it wasn't showing in this scene. So we can just do it. We can head here and the counter also. We'll just fix its position in the center. Now I suppose that it will be showing all the scenes correctly. So far so good. Now let's move on. So I won't really demonstrate the variables on our code. I think what's really matters is to demonstrate these functions and if conditions and the loops on the code. So I will not be demonstrating the variables on the code. So here we have our ground, and we demonstrated these ones, and the ground array length. This is for just the distance between our player's car and the ground is bigger than this, so it's considered to be on the air. So I'll just, yeah, it's recording. So, and here we have the drag on ground, and the drag on ground, this is just for the gravity. When our car flies, we want to add gravity to just pull it on the ground fast to just make our car movement, or when our car on the air. We just wanted to make more reality to look more real. And then we have attaching the engine sound. We attach it here, and then we have we can skip these ones, and this is for Boolean for SI. So this is just for Boolean for storing whether this car is our player's car or our AI car. If it's our AI car, so this Boolean is going to be true, and if it's not our player's car, so this Boolean is going to be false. And then we have the current ground, the current target. So the target is actually the checkpoint, so we want to know what is our checkpoint to make our player's car hit to in order to know to just determine the lab, in which lab are we, and if the player's car has if it has gone through all the checkpoints or not. And we have a vector for the target point, and this is position of the target of our target, a vector which has the dimensions x, y, and z. And here we have the float, public float AI accelerated speed, and all these things will just be down here also, so I'll be explaining below also. And this is for accelerated, AI accelerate speed is for applying acceleration of the car, and AI turn speed is for adding turning feature to the AI car. AI stands for the AI car, and AI reach point target is just adding diversity in order to the AI cars not to drive the same way. We just want to add diversity between them, to just not to drive in the same way in the same road. They will just be stacked on each other. We don't want this. We want just to look like there are several players playing with me, but actually they are not players. This is our computer. And then let's start with our functions. So this is the real thing here. First, we have the void start function. Well, the void start function actually runs just one time in our code, and it runs just right when our car starts. This function plays just once, and it doesn't play again. But the update function, yeah, it runs many times when just it goes through everything, and then it runs again and again and again. But this start time just runs once. Just like it's written here, just start is called before the first frame update. Just right when the game starts, immediately this function is called or invoked. And here we have the RB transform parent. We are setting that the so right when our car starts. So what this means, I'll demonstrate it on our code. We have RB stands for the rigid body. So when our game starts, the rigid body, which is in our car, where the rigid body, our rigid body is the sphere. So when our game starts, this sphere will not be a parent, will not be a child anymore for the free racing car yellow anymore. It will just be right here, a parent for the S1. It will not be, it will be a child of the S1. It will not be a child for the free racing car yellow anymore. And then we here add the drag on ground equal to rb.drag. So we are just saying that the drag on ground is the default one of the rigid body. And here we have the UI control instance lab, the lab counter text. And well, I'll go through the code, the UI script later on, but this is just for the UI stands for the user interface. So we are just adding elements or objects to the user interface, which are these objects. We'll make it 2D to see them better, like the tree, the position, and everything, and the hidden things right in here. Also, these are UI UI objects, and this is an if statement to determine. So this if statements will just work for our AI players, AI cars. If this is the player's car, so these things, these codes, this line of code will not work for it. And what this line of code says is that target point equal to race manager instance all checkpoints. So in this code, we're getting access to the race manager script. Race manager script. We just invoked the all checkpoints function from the race manager script, and we just created an instance of a class there, an instance or just a it's an instance, instance of a class or an object of the class, and we add transfer the position to it. So here we just make the AI cars moving to the checkpoints, and then we invoke the randomize all target function. Here we invoke this function, and I'll talk about it a little bit later on. And here we added AI speed mode equal to random range. So we are randomizing our speed, our AI speed from 0.8 to 1.2. So we are randomizing the range. We here every time we go through this, through this AI function. Random number of this function will be stored in the AI speed mode variable. And then we will go through the private update function. This is for if not, this stands for not, just like an operator, a logical operator. If this is not, this is starting. So we will start the lab. If we started our game, display the UI only for the player's card. This is just for, sorry, if this is not the start, so run this code. So what will we do? We'll just here increment the time by the previous one, the time by the previous one. And here, if this is not our AI car, which this means if this is our player's car, so run this block of code. If this is the AI car, so please don't run this block of code. And this block of code, what it does is that here in this code we are just the time spans from seconds. We're just making the time spans to seconds, just the seconds here. We're just making the time span. And here we're just demonstrating we are adding elements to our UI controller, to the user interface. And here we went to the UI control script. We accessed it with a static static code of line, and we have here there we have a class, and we are making an instance of this class, and we access the current lab text variable or function from there, and it has a method called text. And then we define the format of the thing that will be shown on the UI control. It will be shown in minutes, and here we have the seconds, and here we have the milliseconds. So we have the minutes, we have the seconds, and we have the milliseconds. And then here we say that move the car to the track when the R button is clicked. So when we click the button R, our player's car will be moved to our track. We will just go through this reset to track function later on. So when our car is running, I'll demonstrate it later when I play with my car. When I click the R button, my car will be moved to the nearest checkpoint. And here we added the sound of pitch. So what this do is that when my player's car, this code is just for the player's car. So when I just move my car forward, when the car is moved, increase the pitch when the velocity increases to make it more realistic. So when my player's car is going faster and faster, the acceleration is just going faster. Please accelerate. Please raise my pitch. Here we have the fixed update. Update is called once per frame, so it's called multiple times, many times, in our game. And here we have that, well, at the first, the grounded is equal to false, but then it will be true because it lands on the ground, so it will be true later on. And here we have the Raycast Hit, and this is for detecting the distance. And here we have a vector, and this is just like it's written here. It's basic orientation of the car. We want it to be 0, so we want it to be straight, in a straight line. And here we have a function for detecting whenever the car touches the ground. So when if the car is on the ground, so make the grounded is equal to true, and get the normal of the car. So when our car is on something, I can make it right here, but just to save time, I've already demonstrated it on the third assignment, so I will not be doing it again. But when our car is just on a barrier, so get the normal, move the car to the normal of this barrier, so the car will be perpendicular, the perpendicular vector on this barrier It's just math and physics. And then we have, if this is not our AI card, so this code will run just for, this block of code will run just for our player's car. It will only be working on our player's car, and this code is just for preventing the player from controlling the AI car. We don't want the player to control our AI car. It will just be this one. And here we have the speed input is equal to 0 at the start of the game. We don't want the car to run immediately. We want it to be just we want it to be stopped, but when the player click the forward button or the W button, so if the vertical is bigger than 0, we have it here on the in our settings. Well, I'll not be just where is it? It's just different here on my Mac. Well, I don't really have to show this, doesn't really matter that much. So it's just when I click, when the input get access to vertical is bigger than 0, so it means that the car is moving forward, and it's done by clicking the forward button or the W button. And here is the car, so accelerate our car forward to the forward. And when we click the backward button or the S button, accelerate our car to the other direction, And here, turn input is equal to input.axis horizontal. Oh, and then we have the things. And here, we have the else. This code will run only for the AI cars. This code runs for the player's car, but this one runs for the AI cars. And what it does is the target.I equal to transform to position.I. This actually means that moving the AI cars in the y-axis. We just want to move it forward or backwards. So we will just use we'll just move it in the y-axis, which is this one. We'll just click here, this one. Sorry, we want to just move it in the right one. I can close this tab and open it one more time to just save time. Display here, we can just move it right here. Target a position y, transfer the position y. A vector, the distance. What this code does, it compares the distance between the AI core and the target point with the checkpoint. If it's smaller, then condition is true. If it's smaller, then they are reach point range, so this condition is true and it will be run. So we want to increment our current target by 1, so we want it to move to the next checkpoint. And this one, when the AI core complete a lap, we set the checkpoint to 0, so when our car complete all the checkpoints, it has run through all the checkpoints, reset it to 0, so we will start it one more time over and over again. And do it over and over again. And then we have the target point, and this is for adding diversity to the AI cars, this code. And we also here invoke the randomize all target function one more time here, but in this time it's in the update function. The previous time it was in the start function, which is called just once in our code, but this fixed update function, it's called multiple times, many times. It's called every frame, it's called once in every frame. So if our frame range is, if our frame is 60 so this per second, so this function will be called 60 times per second. If we have, if period is 100, if it has 120 frames per second, so this function will be run, just 120 frames per second also. And then we have gone through this one. Oh, yeah, we've gone through these things. So here we have the vector target direction. So this is the distance between the AI and the target. This is the target point minus the transfer, the position. And here we have the float angle, and this is just for storing the angle between the car and the checkpoint. The checkpoint is a target and the angle variable. We define this angle variable and the start of this code. And here, just for obtaining the sine of the angle, we want the sine of this angle, we use the math app library to do this because, yeah, we don't actually want to make it complex, but just keep it simple. And in this line of code, we're just saying that if the position is less than 0, so just multiply it by minus, so we will get the, it's like saying, get the model of this number. So if it's negative, it will be positive. If it's positive, so it will stay positive like it is. And here, then we have this math app, which I just, if the math.abs angle, ABS just for the model, is less than the AI next turn. So when the car moves on a straight line, run this code just to make the car move in a straight line. And else, and here, how fast to accelerate the car on turning. This is just for accelerating the car, move towards on turning. And this one is just for the speed input. The speed input, to make it more diversity, we add the AI speed input multiplied by the forward acceleration multiplied by the AI speed mode. And then, if our car is grounded, so this code will run only when our car is on ground. So when our car is flying, when our car jump over a barrier or something, this code will not be run. This will not be working. So we will not be able to rotate our car when it's not on the ground. When it's not on the ground. And when it's when our speed is 0, we will not be able to rotate our car, and when it's not on the ground, we will not be able to rotate our car. And then we just, to make our car more realistic, we use the Hunterian Euler to just move the wheels to the left and to the front to make our movement more realistic. We can just see it right here if we just click on this button. Oh, we have to run our code first. It will take time, just a little time. Leave it all as it is. And then we have the, like I said, and here rotate the car to match the normal. If it's in the ground, if this car is in the ground, so the rotation, you want the normal target of the thing, so we want to rotate the car to the normal, which is the perpendicular of this object. So we can, I think we can show it right now. So our wheels will be moving like this and that, just the front wheels, not the backwards wheel. We can just change it from our script. We can add here, where is it? We can the right, left, or rear, left wheel, the rear, right here. So now our back wheels will, the ones that turns, but we actually want the front one, so I'll just end the code and everything will be reset like this to the normal. Okay, and then we have the accelerate only on the ground. So when our car is on the ground, we want to add speed and to accelerate it. So when our car is on the, when our car flies, this is just for the player's car because we don't have access actually to the AI player's car, sorry. So when our car is not on the ground, we will not be able to accelerate it, we will not be able to turn it, and so we will not be able actually to add speed to it, because if there is no acceleration, if the acceleration is 0, so the speed is constant, we cannot add it, and the speed will just drop down. It's just simple physics and math. And then when our car is not on the ground, so when our car flies, we want the drag to be less. We want it to be 0.1, so to just make it more realistic. And then we have the repeated at first here. This is for at first we want to transform forward speed input multiplied by 100 100 1000. So else this is for sorry we were here the else the gravity mode here multiply times to just here to just make the drag like I've already mentioned. And then we have the things here. Let's also talk about this one. Here, this code when the velocity, when the magnitude is more than the max speed. So to make our car reach a specific, to just limit our car's speed, we added this line of code. We don't actually want to make our players' cars speed infinity. We just limit it. So we use this code to limit our car's speed. So when our car speed is more than the max speed, which we defined earlier, the rigid body, the velocity is equal to the rigid body velocity dot normalized times max speed. So we just make it from 0 to 55 or 0 to 1 like it's written here and so on. This is just for limiting our player's car speed. And then we made a class here. The public void is just for a class. We're just defining a new class, and this class will make instance and the objects of this class. This is just the object-oriented programming orientation. So here we have the checkpoint hit class, and this is just for returning the checkpoint index that was hit by the car. We just want to keep tracking of this thing. So here, if the checkpoint number is equal to the next checkpoint, so if we pass through this one and the next, and we will go to the next checkpoint, if we hit it 1, so please increment our next point to check. And if we reach it, if the current checkpoint is equal to the previous checkpoint, so the variable next checkpoint will be incremented by 1. Just for what it does. And this is for setting the checkpoint variable when a complete lap is done. So when we go through all the checkpoints, please reset it to 0. So we'll start a lap one more time. And this, we can go through this one, and then we will just examine all of this one more time. Again, not one more time, we'll just do this later. So the lap, here we invoke the lap completed function. So let's go to the lap completed function. And what it does is that when we go through all the checkpoints, so please increment the current lap, which is this number here, by 1. And then if the lap time is less than the best lap, so or equal to 0, so best lap time is equal to the lap time. So when we can just a second, let's add. Oh, it's not working. What's wrong? Okay, we have, let's just exit this. We don't want to maximize it. Let's add this here. So our best lap, when the lap time is less than the best lap, so this time will be our best lap. So we just made a new record, so it will be in the best lap. So the lap time, and here if the current lap is equal, and this function is for just resetting the checkpoint variable when a lap. Well, this thing is just for like it does, like the current lap is less or equal to the race manager, just in essence the total laps. So the lap time is equal to 0. Current lap is so when we do all the things, so we just here, this is not the AI car, so just to ensure that we will not update the best lap for the AI cars, we just want to update the things. We want to track the lap time and the best lap time and the laps and the position just for our player's car. So we will just display the lap time, the best lap time, and the total laps for our player's car, not the AI cars. So this is what it does. And here we go again, the UI control. script, we go to it and we make an instance to the best lab text class, and we access it in static method to just keep it simple, like I said. And this is here is the format of the best lab time will be in minutes, seconds, and milliseconds. And here is the local counter text. This is for the total labs. It will be just the current lab slash we'll go to the race manager script instance of this total labs. We'll go to this instance and we'll just get the total labs variable or method or just whatever it is, number, and we'll put it right here, and in this case it's 3. Here, if and here if the race else if the race is finished, run this block of code. So this code will just be run when the race is not finished. Is finished, sorry. So if this is not the AI core, so is AI make it true. So when we finish our race, stop the user from playing, so deny any access from the user. So when the race is finished, the user cannot access the player's car anymore. So it will just, so our AI car will be just as simple AI. So our player's car will be a simple AI car. So the user will have no access over it again. So it will just act like an AI car. It will just move and accelerate. It will just turn just like the AI car. And here we are, AI speed mode is 1. And here we have the target point, the checkpoint, like the AI cars. And we added here the randomize target function to just make our player's car move randomly, just like the AI car. And here, this is for displaying the best time. So when we finish our race, we want to display the best time, the best lap time text. And we want to invoke the finish race function. So we can just open the race. Where is it? The race. What a name? Oh, race manager. It's a function in the race manager. Oh, okay. We will go to the race manager later on when we finish. Oh, actually, we have already finished this code. Here, this function randomize target, which we used a lot in this code. It's just for making the AI car moves differently in different speed and the X and Y, X and Z function, in X and Z direction. Because here we have in the scene, the X direction is forward and backwards, and the Z direction is just moving the Z direction is just moving our car forward and backwards, and the X direction is moving our car to the right and to the left. We can do it like this to just make sure that I said it correctly. Oh, I can just close this scene, close the tab, and open a new tab here. That tab with the scene. So yeah, the Z is the forward and backward direction, and the X is the right and the left direction. Okay, so here we were here, the randomize target. And then reset the track. So when we click the R button on our keyboard, this function will be played. Yeah, we were ready to talk about this later. Oh, sorry, later on. Let's just copy this and find this function. Yeah, it's here. When we click the R, get the key down. When we click the R button, just run the reset to track function, which is this one. And what it does is that this is just for subtract one from this checkpoint to move to the previous one to make our code moves to the checkpoint. And if point to go is 0, so if this is our first checkpoint, which is the index 0, where is it? We have to go to the checkpoint. We can close the things. Yes, just like this, this, and this, and this. So in the race manager, we have the checkpoints. We can checkpoint with index number 0. Where is it? Oh, it's not showing. Probably yes. So the element when this is our checkpoint, which has index 0. So if we subtract 1 from 0 will be -1, and we don't have an index for -1 here. So if this is the checkpoint with the index 0, so please get the length of this array, because all checkpoints are stored in an array in the race manager script, which I'll talk about later. So get the length of this array and subtract 1 from it. So it will be the last one. So this array is just 24, subtract 1 from it. So we will move to the element number 24. Okay, so far so good. And then we have this thing, which is the point to go we talked about, and then we have the transform to position. So here to store the position, to transform to the position variable. Here we have the rigid body. We want to transform the rigid body. If we transform the rigid body, so we actually transform all the car, because the rigid body is part of our core. So move the sphere to the point to the position, because the sphere is our rigid body in this case. So here, the rigid body, the velocity is equal to vector 3, the 0, so we set the speed of the sphere and the car to 0, and we want the car to be forward. We want the vector is to be 0. This is the normal. And here we have the speed input to 0, so our car, when it's moved, the speed is 0. We have to click backwards and forward button in order to move our car. And the ground here, the turn input is equal to 0 to reset the turning to 0. So our car will not be moving to the left or to the right. It will just be 0, just like the speed. So we've already talked about everything in the car control script. Yeah, we are recording this, so we can do this. In our game, we can add it here. I don't know why it's just, oh yeah, it's better now. Okay, I'll just wanna go with this one. I wanna start the game where I'll just wait a second till this code is loaded, and I'll just open a new script, which is the race manager script. I'll just do something here. Sound. So our engine is working. So our engine is working here. But like you can hear it, because I already turned it off. I'll just not to bother with this sound. We can just turn it off again. And let's open the race manager script. And let's open also the checkpoint script and what is this one? Checkpoint. This is the checkpoint controller. Disable over time. Main menu and the play sound. The UI control. So let's talk about the UI control. Oh, let's leave it in the end. Put it right here. Race manager. Now let's talk about the race manager. So here we're just saying the checkpoint array. So array, we store our checkpoints in this array, and to just array for the checkpoints and providing reference for the checkpoint script, which in our code I showed them already. Well, let's show them one more time. The race manager, which the reference is the thing, we just match the first quote this lock, this lock. And our total labs is equal to 5. Then we have the car control. This is just for a reference to the player car, and this code is just a list reference to the AI car. No, it's just making a new instance or object of the class, and so on. And here we have the public integer player position. This is just the display position variable. And here we have the float, the thing defining the maximum speed of the AI and player's car, defining the maximum speed and acceleration variance and the speed variance also. Here we have the boolean that is starting to detect whether the race has started or not. So if the race is not started, this variable will be false. If it's started, this variable will be true. Oh, sorry, if it's not started, so this variable will be true. If it didn't start, yeah, so this variable will be true. If it has started, if this variable will be false. So time between start count. So this is the counter's step. So it will be 3, 2, 1. It will not be 3, 2.5, and 2, 1.5, 1, 0.50. It will be just 3, 2, 1, or 5, 4, 3, 2, 1, just like we will show later. And here's the start counter. This is the float. Of which number our counter will start, and we later on will just keep subtract this value from this one. And here we have the countdown current. This is 3. Near the race completed. If our race is completed, this variable will be false. It will be true, and if it's not completed, this variable will be false. It's just for the displaying the like the main menu and other things. Here we have this thing invoking the race manager instance. Okay, and here we have the start. I've already talked about this. I will not waste any more time on this. Just explain the things that I've already did. This is an automatic counter for checkpoint in the race tracking. We don't actually want to keep counting each one. So this one, these 3 lines of code will done everything for us. And here we have the index. Here we have the is starting equal to true. And what it does is that start the counter once the game started. So this is what it does. Here start counter equal to the time between the start counter. And here we display our counter on the UI interface, which is 3, 2, 1, and so on. And here we have the update is called once per time, one more time. And if it's starting, so our if the game is started, so the start counter is decrement it the countdown current by 1. And here we have this, and then we have the thing. We have the start of is equal to counter, and then we display it on the UI controller. And if it's equal to 0, if we reach it 3, 2, 1, 0, this value is 0, so our game will not be started anymore. So the starting is equal to false, so all the car will move. So we just say it on the car controller that if the starting is false, so our game will be started. We can move our car. On the AI car will be moved automatically. And here UI control, in essence, the countdown text and the go text, the countdown text will be false. So once this is done, the countdown, where is the canvas? At the start of the game, this will be true. Not sorry, not this one, but the counter. Yeah, this one will be true. And once it reaches 0, it will be false. And the go will be true. And then the go text will be true. Else, the player position is equal to 1. We want here the player position to be 1. And also for each car controller, we want to run through the array, all AI cars array. We'll go through it. If AI car, the current lab is bigger than the player car current lab, so the player position is equal to +1. So if any AI car position is more than this of the player's car, so the player's car position will be increased. If the AI car the current lab is equal to the player car the current lab, so if both AI car and the player's car are on the same lab, here the AI car is position, the AI car lab is more than the player's car lab, so the player position will just be decremented, will be increased, sorry. And if they are in the same lab, so we will check the checkpoint. So we will go to the checkpoint in order to know if our car is in front or in the back of the AI car. So if AI car, the next checkpoint, is bigger than the player card at the next checkpoint, so the player position incremented. So it's that if the AI car is in forward of the AI car is in front of our player car, so the AI car, yeah, it's just moving faster than our player's car. But if the AI car is in the same position, they have the same checkpoint. If the AI car and the player car have the same checkpoint, so we will check the vector, the position of the vector of these both. So if the position of the vector of the AI car is less than the player's car, so increment the position of the car by 1. If the AI car's distance for the checkpoint is more than the player's distance from the checkpoint, the position of the player's car will be incremented by 1. This is just increment. And here we're just adding object to our user interface, and in this case, the position text, it will be the player's position from all the thing slash all cars that count plus 1. So all our AI cars, in our case, are 3 or 4 plus 1, which is our player car, because there is going to be just one player. And each player just has one core. It's logical. And here we manage the speed variance to our player position. So if the player position is equal to 1, so the speed variance, so if our player position is 1, we want the AI cars to move a little faster in order to catch the player's car. We want the speed to be more just finite. So if the player's car is number 1, the speed of the AI car will be increased. But if our player's car position is not 1, so we want to make the cars that has already passed the player's car, we want to lower to make them move, to make their acceleration lower. And here, when our race is finished, we use this finish race function here. So yes, we use it here in this one, sorry, in this instance. So we have here, we made here a class for the finish race. So when this function is invoked, our race completed will be true, and we want to use a switch condition. So in the first case, we will just here once the race is completed, change the value of this boolean to true, or the race completed boolean to true. And here for creating statements for different position of the player's car at the end of the race using the switch case. Logical. If the player finished at the first place, so display this case in the UI. And if his position is at second, so display this case. If his position is the third, so display this case. If his position is whatever else, just display this number plus TH. So with just the 4th, the 5th, the 6th, the 7th, 8th, 9th, 10th, and so on. And here we're just activating the results screen panel. So at the end of the race, we will activate the panel finish race. Will be activated like this. You finished number 3rd, which will be one of these things. It will be this one, or this one, or this one, or this one. It can't just be one of these ones. It cannot be 2 or 3, whatever. Just one of them will be displayed here. And here we have a bottom. I'll talk about it a little bit later. And we finished this script also. So the checkpoint script. Here in this checkpoint script, we have just this line of code where the public integer checkpoint number, and this is just for numbering the checkpoint. We don't want to number our checkpoint where our risk manager. We don't want to go through each one of this and say this is the first, this is the second, the third, the fourth, fifth, and so on. We want them to be numbered automatically. We don't want to waste time on them. If we have just 200 checkpoints, 300 checkpoints, we will not actually go through each one and number them by hand. It will be time consuming and will be so tiring. So the checkpoint control. Oh yeah, checkpoint. Here we have the checkpoint control script, and in this script we're just here we have this. This is the function, and here we have the public core control script. This is just invoking the core control script. You use it in this script. So this is what we've done. This is what we have done here, and here we're just making a class. Private class. So this class can be just accessed, the variables can be accessed inside this class. This is the difference between the public and the private. On trigger enter. Interacting, this is if other the tag is equal to the checkpoint. Interacting with the checkpoints using their tag. So we can add the tags here. We can add a new tag if we want. So our tag, we have the tag for the checkpoint. So this code will work just for this line of code, will work just for any object or anything here that had the tag checkpoint. So here, when there is a collision between a checkpoint and an object, so when there is a collision, checkpoint, hit, get the component checkpoint, dot checkpoint number, and store it here. So we completed this one, display over this, here we have the display over time. Here we're just saying that declaring the variable for hiding the go after 0.5 seconds. So please, here we're just time display minus the time that delta time, and here if the time that this time to display is less than 0, is the time to display. When we go through from 0 to 5 seconds, when we go to the 0 second, set active false, get an object. So after half second, display inactive this object, this panel, sorry. So after the race is, after the starting variable is false by 0.5 seconds, deactivate this code, this panel. Sorry. And here we have the plain sound on collision, where let's start our race to prove that our sound works. Here we have the start is called before the first time. The same thing one more time. So our car exit race, play. It's just play. Wait, I didn't, I'll just do this. Oh, I forgot, I just turned it on while I was playing. Let's just turn this on. The sound is not working. I'll just turn it on in a second. We will move to the free racing car. We have all the engine sound, and let's audio source turn it on. I don't know why it's not. Oh yeah, it's working now. So it works. It does work. Let's turn it off and turn off the sound also. Oh yeah, we will turn it off from here. So here, play the sound when the sphere collides with the cube. and defining a random pitch degree each time of the collision, and here the stop and then play, and that's the code, this code, and that's what it does. And here we have the main menu.cs. So here we have real things. Here, the first thing, we're connecting the scene libraries to switch and manipulate them because they are in different, what is it called? In different space. So we are connecting the libraries of different space using this one. And then we have what it does, public level to load the game scene. So level to load is our game scene, which is this one, and the main menu is the other scene that we have, which is so this is our overlay, and this is our main menu. Okay, let's just save. So we will just switch between them, and these are stored in the script, in this function, which is, oh sorry, they are saved in the script. We just added it to our script. Yeah, so in the main script, the level to load refers to the S1, and the main menu, one more time, in the canvas, sorry. And our main menu refers to the main menu script. This is pointing to this, and this is pointing to this. And then we have the functions. So when we click the point start game, so we have here the function start game. So we have it right with game. Let's just start our game. Why? Let's wait. I didn't start with the same. I have to open the same. If I click, let's start our game. So when we click the button of that refers to the this function, we will load the level to load scene, which is the S1. And when we click the back to menu button, we will invoke this function, which just loads the main menu scene. And then time.scale is equal to 1, just make it true. And the quit game, when we click the quit button, it will just invoke the quit game function. And what it does is just quit the application. I will just show it later. I can just close this one. So here, what I really want to do, oh my gosh, it's just here we can, what I wanted to do, I forgot what I really wanted to do. We have here the button. If I click here, so we have this panel, which is the main menu panel. So in the canvas, we have which panel? Yeah, the panel pause. So here we have the function, the button. Where are our buttons? We have the buttons here in our panels. So when we click the button resume, we run the UI.control, the pause function. And when we click the exit race, it will go to the main menu script, back the menu script, which is this one, like we said here. And then we have the button, the last button is the quit game. It will go to the main menu script, .quit game, and we'll just invoke the quit game function in the main menu script. And we have finished this one also. And the UI controller, and the script, yeah, this is the last one we have. Here we're just accessing the static members of the object. Control, we just make these things statics in order to access them more easily in the other scripts. And here we have the lab is just for declaring these are just declaring the UI variables, user interface variables. Here we just TMP the text, and here we have the current lab text, and this is the lab's number, and then the best lab text is just the best lab for the player of the player's core, and then we have the lab counter text just for current lab timing. Best lab text. Then we have the lab counter text just for the current lab counter. Is just for the current lab timing. And then we have the position text is for the current rank of the player's car in the race. And then we have the countdown text is just for the starting counter variable. And the go text is just displaying the go world after 3 seconds of when the game's starting. And then we have the result text, and it's just for the position of the player race result. The text is just, it's just the position of the player at the end of the race, when the race is finished, when we completed all the laps. And then we have the result screen and pause screen. This is a boolean, the game object result screen and pause screen. It's here, the canvas. We have them, we have them here. This is connected with the panel. Which panel? The panel finish. And this one is connected, and the other one is connected with the panel pause. This is the panel. Where is the thing? The panel finish, and this is the panel resume. And then we have the update function. When we click the escape button, pause and pause. So it will just invoke the pause and pause function, which is just displaying this menu. It stops our game and displays this menu. So it's paused, make it. If it's paused, make it just revert the value of it. If it's true, make it false. If it's false, make it true. Pause the screen, set active is paused, so set is paused to active. And if it's paused is true, so the time scale is 0, stop everything, else run everything. And that's for the code. I'll just now run our game. So we have already deployed our game. We're to build settings. We built our game, we'll deploy it. We made a deployment for our game. Yeah, we can. The player settings, we have here the editors, we have the input manager, we have everything here also to just manage everything. So we have built our game. In my case, it's a Mac. So we can quit everything now, and this is our game. This is 2 different versions of the game. I'll run this one. I've already displayed everything. I can just now wait till it works. Let's just wait a couple of seconds. So this is our main menu scene. If I click play, if I click quit, it will quit our application. Like just was mentioned in the main menu script, I've already closed it. There was a function for quitting the game, or just invoke the quit.application function. Oh, I already quit it. Let's run it one more time. And here we have the play. Oh, I just have to make sure that I have space on my Mac. Oh, I think I have already space. We can just start our game. They are not fixed. I can just fix them easily like I did. Now our car moves to the checkpoints. Oh, I missed some checkpoints. I'll just resume. I will just make it like this. If I click the art button, my car position will be reset like this to the checkpoint. And I don't really play this game much, so I don't know how to play it well. Oh my god. or if you finish the fifth phase. So we have just one lap to make it fast. If I click on the skip button, this menu will be displayed for me. I have another version of this game and I fixed everything by myself. So this is the game that have already been built. I imported it from GitHub, but I built another version of the game, which is this one. I have a lot of cache files, so I'll just remove everything to run everything faster. Let's run the game. This is the car I built by myself. Oh yeah. So here we have the play. We want to quit. I fixed everything. This is fix it now. And then we have the time where I wasn't showing because the cache memory is. Let's exit the race and play it one more time. Oh, I forgot to display the thing and I said it. So everything works well. Probably. Let's do it again. Let's play one more time. I hope it will work well this time. Let's play. So yeah, it works well with you this time. Let's just complete this lap. So our rank is now the second, the fourth. I hope I'll be the first, but obviously I will not be the first. But at least I'm not the last yet. Or I can just make it like this. Yeah, now I'm the third. Now still the third. Oh, I finished the race. The fourth. Yeah, that's good. Not bad. So that's everything for the game. I demonstrated everything. Thank you.